Okay, we're going to describe how to do the constant velocity tubes lab that you're going to perform tomorrow in class. You should have received a lab handout today in class. If you didn't, that's okay, but if you did, follow along. Make sure you understand where everything goes on the lab handout. And if you didn't receive it, you'll just get one tomorrow. Okay, so the idea is that you're going to create a graph that shows the position of this air bubble that moves through the tube. You're going to create a graph of that position versus time. And we're going to see that graphing motion is one way that we can understand what the motion is, how things behave. So you want to always start with your bubble all the way in the covered end. So I'm holding it nearly horizontally, but so this end is higher so that I know that the bubble is all the way at the end. And at the time when your lab partner tells you to go, you're going to turn it vertical. Mr. Bickerton is acting as my lab partner today.
Ready?
Yep.
Go.
Okay, you're going to follow the bottom of the bubble with your forefinger and
Stop.
thumb.
7.55 seconds.
Okay, so Mr. Bickerton's going to record the time, and we're also going to record the position of the air bubble after that amount of time. We're going to measure the position from the end, and we could use any units. We could use feet, we could use inches, we could use meters. We're actually going to use centimeters in this case, and there are a couple reasons for that. In physics, we tend to use, in all of science, we use SI units, International System of Units. In physics, we kind of use a subset of that. MKS units are, M stands for meters, K stands for kilograms, and S stands for seconds. So that means we would use meters for length, but since this is so short, it's not even a meter long, we want to use something that just denotes a smaller portion of a meter, which is why we use centimeters. So I see that at that time, when Mr. Bickerton told me to stop, the bubble was at the 58.5 centimeter mark. And you're probably going to be able to only measure within half a centimeter because of, our measurement technique isn't perfect with our thumb and forefinger. So you do it once, then you let the bubble get back up to the top and repeat. You're going to end up doing 7 times. Mr. Bickerton and I are going to do fewer just so we can demonstrate the point to you, but you'll do more data. Okay?
Ready? Go. Stop. 6 seconds exactly.
Okay, after 6 seconds, the bubble was at the 39.5 centimeter mark. Okay. Again, I want to get the bubble back up to the covered end. Okay.
Ready? Go. Stop. 3.81.
And at that time, the bubble was at the 32.5 centimeter mark. Do one more data point.
Sure.
Okay.
Ready?
Mm-hmm.
Go. Stop. 4.74.
31.5.
31. Okay.
What's up with that? All right. Let's collect one more data point from higher.
All right.
Someplace more than 6 seconds. The more you'll see that the more data you get, the better you can see what's going on. And once you graph it, you'll be able to tell what's going on a lot better as well.
Ready? Go. Stop. 7.71.
50.5.
50.5.
Okay, so now just looking at the data table doesn't really tell you a whole lot. It just looks like a whole bunch of numbers. You can see some general trends, but you can't see much by looking at the data table. when we put this into a graph, we'll be able to understand what happened a lot better, and we'll also be able to see if any of our data was kind of messed up. So, obviously I'm not going to be able to show this exactly at 7.55 seconds. So I'm just going to have to approximate where exactly these numbers would be. But 7.55 seconds and 58.5 centimeters. I'm going to go close to halfway between 7 and 8. And then the position is 58.5 centimeters. Going to be close to 59, close to 60 for that matter. I think we're about there. And then at 6 seconds, we were at 39.5. 6, just about 40. 3.8, 32.5. 3.8 would be here. 32.5 is going to be about there. 4.74 and 31.5 looks strange. 4.7, 31.5. Okay, about right there. And 7.7 and 50.5. 7.7 and just over 50. About there. Okay, so now if this were, if you're a business major and you're talking about the stock market, you might just connect the dots. But in science, we don't usually just connect the dots. We want to see the general trend, what's going on here. So a better way to show the general trend is something called a line of best fit, which you may or may not have used before. The line of best fit basically cuts the data in half. And this data actually is a pretty good set of data for cutting it in half. We've got a couple points above the line and a couple points below the line. It actually does show a pretty straight line trend with some variation. So we're going to basically cut the line in half using a straight edge. You always use a straight edge when you draw a line of best fit. Do not try to draw a line of best fit without a straight edge. So we put our straight edge right in the middle of the data. And you see that we have a straight line that pretty much cuts our data in half. And you want to continue your line of best fit all the way back to the y-axis, even if it happens to go, you know, it can go above 0 here. It could go to 0, 0 possibly. And it could even end up down below 0, 0 depending on how good the data was that you collected. But you do want to continue your line of best fit all the way back to your vertical axis. And that's because one of the things we're going to do is write the equation of the line. And you might remember from math class, one way to write the equation of a line is using this general form y equals mx plus b. So we're going to basically figure out what the slope of the line is and the y-intercept of the line, and then write an equation based on that. One other thing to note, I've only shown one data set here for my red tube, but in fact, when you do the lab, you're going to do the same thing with 2 other tubes, so maybe a green one and a yellow one, and then you're going to put all of the data onto this one graph. But so you're going to have 3 separate lines in the end, one for the red tube, one for the yellow tube, one for the green tube, or whatever colors you use. You want to be able to distinguish between those colors. And to do that, one way you could do it is to use colored pencils. Another way is to use different symbols. It'll also make your data a little bit easier to see. So you can use points first, but then go back and put a symbol around it. Maybe you might do a triangle around each of the red data points, like that. And then you're going to put a key off to the side that shows that those are for your red one, and maybe you'll use a rectangle or a square and a circle for the other 2 shapes. But you want to be able to distinguish between the various data sets that you have, and I would do it one at a time. Put all your data on from the red tube, put a symbol on them, put a line of best fit, then do the data from another tube, because hopefully you'll be able to, you won't get too confused that way. That's about it for today, and we'll see you tomorrow. Thanks, bye.